The last flip-flop that we are going to look at is the T flip-flop, and here T stands for toggle. We have already looked at the toggle operation in the JK flip-flop, and it's very much similar to the T flip-flop as well. But first, let's construct the block diagram. A T flip-flop will have one input T and the second input clock. It'll have a Q output and a Q prime as well. Let's look at the truth table for the T flip-flop. So input T, Q, current state, and Q plus next state. So 4 combinations. When T is 0, it's just going to be in the hold state. So when Q is 0, it is 0. And when Q is 1, it's going to be 1. That's the hold operation. When your T is 1, your Q plus is going to be the inverse of Q. So if Q is 0, it's going to be a 1. And if Q is 1, it's going to be a 0. So that's the toggle operation. Let's take an example to see how this works. Assume that we are working with a rising edge triggered T flip-flop. So we are only interested in the rising edges of the clock. And this is your T input. Let's say your T input is initially 0, 1, all the way, and then finally a 0. Let's assume that the initial value of Q is a 1. So how would the system respond? Or how would the T flip-flop respond to this? So until the first rising edge, you're going to hold the value of Q. At the first rising edge, T is 0, so we continue to hold the value. At the second rising edge, T is a 1, so we have to do the toggle operation. Since Q is a 1, now it's going to transition to 0 after a slight delay. At the next rising edge, again you have T as 1, so we are going to toggle the value of Q, and it becomes 1 after a slight delay, of course. And finally, at the next rising edge, you have T equals to 0, so basically we are just going to hold the value. This is how a T flip-flop works. T flip-flops are used in the construction of frequency dividers. A frequency divider is a circuit which has a signal come in at an input frequency of f, and you give it to the T flip-flop or the frequency divider. Your output is going to be f over 2. So it's going to divide the frequency by half. So for example, if you have a 2.4 gigahertz signal and you give it to a T flip-flop, it is going to produce a 1.4 gigahertz signal. Frequency dividers are used in the construction of counters which can count exactly after 1 second or 2 seconds or 3 seconds. So as you know that in your systems you have 2.4 gigahertz. Now we can convert this into 1 second if we want to, using a required number of T flip-flops. So 1 second corresponds to 1 hertz. And 2.4 gigahertz is basically 1 over 2.4 times 10 power 9 seconds. So that's a few nanoseconds.